Hello students, in this video we are going to discuss how diode can be used as a half wave rectifier and a full wave rectifier. In the last video we studied like this: diode will conduct only when it is forward bias and does not conduct when it is reverse bias. That was our conclusion. Because in reverse bias the current is very small, that we can neglect it. So making that as the principle, the diode conducts only when it is forward bias and does not conduct when it is reverse bias. Using that as the principle, we can use the diode as a half wave rectifier and a full wave rectifier. First of all, what is meant by rectification? Rectification means it is the process of converting AC to DC. You can write rectification is the process of converting AC to DC. In our household circuit, the power supply that we are getting is AC. But all the electronic devices like the mobile phones, TV, DVD player, computer, all those things works under DC. So in those devices we need a technique which converts AC to DC. For that we use diode. So the important use of diode is rectification. Diode can be acted as a rectifier in two types. The first one is half wave rectifier and second one is full wave rectifier. So what is half wave rectifier? Half wave rectifier means it is a type of rectifier which rectifies only the half cycle of AC. AC is having two half cycles, right? If I take an AC, there is a positive half cycle, there is a negative half cycle. That is called one time period. One positive and one negative is called one time period. So here this diode will rectify only the positive half cycle of AC. So let us see the circuit diagram. This is the primary of a transformer and this one is the secondary of a transformer. So you can see primary is having more number of turns and secondary is having lesser number of turns. So this is a step down transformer. Okay, step down transformer. And I connected a diode here. A diode is represented like this symbol, a triangle and a dash. The triangle stands for P and that line stands for N. So always remember like that, triangle symbol stands for P and the line stands for N. So this is the PN junction diode. So diode is connected across this terminal and here there is no diode connected. And this is the load resistance RL. Load resistance means the device which we are connecting across it. Okay, that is called load resistance because the device, any device if we take, it is having a resistance. This is our positive cycle. See, for an AC, look at the third figure first. These two figures are only for the explanation and in the exam you have to draw only the third figure. You do not have to draw the first and the second figure, draw only the third figure during the exam time. Okay. Look, this is the AC. AC contains the positive cycle and the negative cycle. Again positive and negative. When the positive cycle comes, that is why I am just splitting the figure into two. The first one is only for the positive cycle and the second figure is only for the negative cycle. For the positive cycle, this terminal will be positive and this terminal will be negative. As a result, what will happen? See, during the positive cycle, this terminal is positive, this terminal is negative. So positive is given to the P side. I already told triangle is P. So positive is given to the P side and negative is given to the N side. So this diode is in forward bias. And when the diode is in forward bias, what will happen? The current starts flowing through the diode. So the current flows through the diode and it flows through the load resistance RL, it completes the circuit. So what will happen? You will get the output. Again, this is a gap. This gap shows there is negative terminal. And again, when the next positive terminal comes, the same thing happens. The diode is in forward bias, diode conducts and you will get the output. And think what will happen when the negative cycle comes. When the negative cycle comes, the upper terminal is negative and the lower terminal is positive. As a result, what will happen? Negative is going to the P side, positive is going to the N side. So this diode is in reverse bias. As a result, what will happen? No current will flow. That is why I have written no output. No current will flow through the diode. So in this cycle, no current flows through the diode. Again in the negative cycle, there is no current flows through the diode. Only during the positive cycles, the current flows through the diode and we got the output. So combining both, if I put the diagram here, during the positive cycle, the diode will conduct and you will get the output. During the negative cycle, the diode is in reverse bias, you won't get the output. This is called half wave rectifier. So for an AC, it just passed through only the positive cycles and it just eliminated the negative cycles of AC. That is why it is called half wave rectifier. Okay. So you can copy this, copy only the third figure and the write-ups. Okay, first and second figure is not required, that is only for explanation purpose. In this type of rectification, the efficiency is very low. Efficiency is only 40.6%. Okay, that means lesser than 50%. Efficiency is only 40.6%. Please write that. And also write the output frequency is equal to the input frequency. Output frequency is equal to the input frequency. And the output will be fluctuating and intermittent. What is meant by intermittent? Intermittent means there is a gap here. So the output is fluctuating and intermittent. So to avoid the intermittency and to improve the efficiency, we are making full wave rectifier. Full wave rectifier consists of two diodes. Half wave rectifier only contained one diode, whereas full wave rectifier consists of two diodes D1 and D2. D1 is connected across this terminal and D2 is connected across this terminal, and both of them are joined like this, and load resistance is connected across this point, and through the load resistance the current is flowing through the central point of the transformer. Current is flowing through the central point of the transformer. So if the current flows like this, it comes towards this resistance and it will flow from B to A towards this transformer. Similarly, if the current flows through D2, again it flows like this, goes to B, and from B to A it flows. This point is called center tapping. It is the center of the transformer, center of this coil, secondary coil of the transformer, which is called center tapping. And center tapping is used so that the potential at this center point will be always 0. We already told this is positive, this is negative. At some other instant, look at the second figure, this is becoming negative, this is becoming positive. So the positive and negative terminal points keeps on changing because it is AC, positive and negative keeps on changing. But this point will be always at 0 potential. That is the advantage, or that is the use of center tapping. Okay, that is the use of center tapping. Please make a note of it. So it consists of 2 diodes. So let us see what will happen. During the positive half cycle of AC, the upper terminal is positive, lower terminal is negative. So diode D1 is in forward bias and D2 is in reverse bias. So the current will flow only through D1 and it will come like this, and it will reach the terminal B and it will flow from B to A. Okay. Now during the negative half cycle, what will happen? During the negative half cycle, the upper terminal is negative and lower terminal is positive. As a result, D1 is reverse bias, D2 is forward bias. So no current will flow through D1. Current will flow through only to D2. Okay, the current will flow only through D2. So the current flows like this and it goes through D2 and it reaches B and again it moves from B to A. In the first figure also, even though the current was flowing through D1, it moves from B to A. In the second figure, the current is flowing through D2, but here it comes from B to A. So in both the figures, the current is flowing in one direction only, that is from B to A. And here also you will get the output. So here you can see the output and here also you can see the output. If I combine both, you will get the third figure. The output is, in both the figures you are getting the output. So you will get the output like this. Even for the upper half, even for the positive cycle you got the output, and even for the negative cycle also you got the output. So when I combine, the output will be like this. There is no intermittency here. That means there is no gap. There is no intermittency here. Both the positive cycle and the negative cycle got rectified. So this type of rectification is called full wave rectification. And in full wave rectification, the efficiency is very high. It is 81.2%, exactly double, 81.2%. And here the output frequency is twice the input frequency. Please write that also. Efficiency is 81.2% and output frequency is twice the input frequency. So here you will be getting a fluctuating DC. There is no intermittency here, you will get a fluctuating DC. Now here also you can see fluctuations. To remove those fluctuations and to get a steady DC, we will use filter circuit. Okay, when we use filter circuit, these fluctuations will go and you will get a steady current, steady DC. For filter circuits, we use capacitor. So we studied that the capacitor will block DC. So if I connect a capacitor in the circuit, the capacitor will bypass all the components, all the AC components, and it will block all the DC components. So we just connect a capacitor, we just bypass the circuit with a capacitor. That means we connect the capacitor in parallel. So all the AC components will flow through the capacitor, all the fluctuations will pass through the capacitor, and only the steady current will reach us the output. You only have to remember those two names. To remove the fluctuation, we use filter circuit, and filter circuit uses capacitor. Okay, so the fluctuations will pass through, will get bypassed through the capacitor, and the steady current will appear as the output. Okay, so that's all for now. Thank you.